Okay, this is part 2 of lesson 7 about earthquakes. This is our final piece of new information for the unit. Okay, so let's talk about what happens after an earthquake. So, when we think of earthquakes, we typically just think about the shaking, but fewer people are injured in the actual shaking, especially in the United States. There are some events that happen after an earthquake that are pretty scary. So you know, so the first danger in an earthquake obviously is the ground moving. And if you are in that situation, you never know. We are not likely to have an earthquake of any great magnitude in Pennsylvania, but you might be on vacation. You might be in the Caribbean, or you could be in California, or you could be in China or Japan. You could be on a vacation and an earthquake can happen because we can't predict them. We don't know when they're going to happen. So it's best to kind of know what to do and have that in your bag of tricks. So if you are in a car during an earthquake, you should just stop and pull over and set your brake. I know you don't drive yet, but there's this, if you are unaware, there's a special brake in your car called the emergency brake. You don't want to be driving because the road could crack, depending on what's happening. The concrete could crack. If you're on a bridge, you get off the bridge and then stop the car. You don't want to be on a bridge in an earthquake in case the bridge deck would collapse. Okay? If you're in bed, they tell you just to roll over face down and cover your head with your pillow to protect your head. If you're outside, stay outside and stay away from buildings so that pieces of the brick or parts of the building itself doesn't fall down on top of you. There is a wives' tale that you should stand in a doorway in an earthquake, but that's actually not true. It's not a safe place to be. You're better off to get under a piece of furniture like a table or a desk, something like that. They tell you not to try and run outside of the building because it's hard to walk in an earthquake. If you've ever done Noah's Ark at Kennywood, that shaking floor, it would be worse than that. A small earthquake would be similar to that, um, but a devastating higher magnitude earthquake, it's really difficult to move, and you run the risk of getting hurt just trying to leave the building. So they tell you just to stay put. Okay. Um, and this is some just a little bit more information about if you are in an earthquake. If you do have to stay inside, try and stay clear of windows, fireplaces, heavy furniture like china cabinets or entertainment systems that could fall on top of you. Don't be in the kitchen. It's a bad place to be. There's a lot of things that can fall. There's a lot of like the gas, if you have a gas stove, or the microwave that's mounted high, or the cabinets that are mounted to the wall, they could fall off, and that becomes very dangerous. Um, if you're outside, you try to get into an open space. An open field would be great where nothing could fall on you. You don't want power lines to fall on you, chimneys, anything else like that. Um, I told you about driving, and you want to, I know you want to stop your car, but you also want to be cognizant of falling power lines and trees and rocks and things like that. And then if you are in a mountain, like if you live on a large hill or you are vacationing in a mountainous area, you have to be careful of landslides and debris that can be loosened and fall over during an earthquake. If you are at the beach, what should you be worried about? I hope that you are saying tsunamis. Um, if you are experiencing an earthquake at the beach, there is a chance that a tsunami could happen. And most places that are likely to have a tsunami have a warning system in most cases. The problem is you only have 15 to maybe 75 minutes to get out of the way of a tsunami, depending on how close you are to the beach. So all they tell you to do is to get as high as you can and as far inland as you can. You would want to be alert for signs such as a sudden rise or draining of the ocean waters. If you've seen a movie, I've seen a few movies with tsunamis in them, they always show that the ocean kind of sucks out, and that is actual factual information that can happen. Um, don't wait to see what's going on. Leave all your belongings. They tell you just to go because you don't have enough time. Now, the tricky thing is if you are out to sea or if you're in a boat, you head out towards the sea. So you wouldn't want to try and get inland. You would want to head out in deeper into the open ocean. You would be less likely to be affected by the larger waves. Okay. And I hope that never happens, but, or even if you're watching a movie so you can understand what you're watching. And next week, next week, I'm going to post a video just for if you want to watch it, you don't have to, but it is about the Japan earthquake and tsunami that occurred in 2011. And it was pretty monumental. So I always show that in class. We always talk about it. And we just kind of ran out of time here. So I'm going to post it at the end if you're curious to see it. Okay. I mentioned that after the shaking is some of the scariest times in an earthquake, believe it or not. The problem after an earthquake is oftentimes there are large fires, and that is because the gas lines get broken. So your gas lines to your house run underground, and when the ground shakes, those pipes can break. And then you have all of the debris that are rubbing against each other, and that can cause a spark, and then things will catch on fire. Because there's a lot of debris and things have fallen, that fire has the ability to spread pretty quickly. And water pipes are also under the ground. So a lot of times your water pipes are broken. And so if you can get to a fire hydrant, a lot of times there's not enough water pressure. If you've ever seen a fire hose, the water that comes out of that comes out at a really high pressure, great speed, so that it can pump a lot of water in a very short amount of time. And when you don't have that, it's way harder to fight that fire. In addition to that, the ground just shook, and a lot of times the roads are broken. And so emergency crews can't get to certain places because the vehicles can't physically get there, whether the bridge is out or the road is collapsed. If you look in this picture, you can see here's your highway, here's the center line, here's the rest of it over here. So all of this road in between has washed away. Looks like there's a body of water over here. So even if the fire company has access to water, they might not be able to get to you. So a lot of people lose their life after an earthquake because of the other catastrophes that happen. Okay, so what do we do to try and protect ourselves in an earthquake? In the United States, we have a good system in earthquake-prone areas to make buildings that are more resistant to collapsing. Same is true in a lot of the wealthier countries that experience earthquakes. I know China and Japan have pretty sophisticated systems to prevent buildings from collapsing, much like we would see out near California. Some of the major ones are the way they build their structures is different. In Pennsylvania, if you build a house, most of the 2x4s just go up and down and they create a frame, pretty standard. But if you live in an earthquake-prone area, they oftentimes use concrete walls with steel bars in them. They call them shear walls, and it helps to reduce the movement whenever the ground moves. They also cross brace the walls, so they have some diagonal supports in them as well that helps to prevent buildings from collapsing. Now, something really cool, this is a little bit more modern, is something called a base isolator unit. And what they do is they put these springs on the corners of the building. So here you can see they're showing you one here, and then I wanted you to see what it actually looks like. And so what happens is when the building shakes, the base is not completely fixed. And so it has a little bit of wiggle room, and it's less likely to fall over because it has the ability to move a little bit with the ground. So that makes it safe. And the more modern ones are usually connected to some kind of computer system that monitors that shaking. Something even more impressive is a pendulum system. And you typically only see this in skyscrapers. You obviously couldn't do this in a home, but in really tall buildings, in the center of the building, they put a very large, heavy steel or metal ball in the center, and it's connected to a cord so that it can swing like a pendulum. And what happens is, if the building would happen to tilt to the right, the pendulum would swing to the left, and it would counterbalance the pull and keep it from falling over. So because that's on a pendulum system, that steel ball can move its weight opposite of the way that the building moves. And a lot of times these are controlled in part by computer systems as well. Sometimes when we build large buildings in an earthquake-prone area, they actually put these concrete or plastic rings around the foundation. And what that does is, as the ground sends waves towards these buildings, the rings diffuse the vibration. And so the building, and you can see here, they're even showing you the base isolation units here. But these concrete rings help to absorb some of the vibration to help reduce that for the buildings. And then not only structures, but just what you build with. A lot of earthquake resistant materials are steel because it is more flexible. You've bent metal before. It has the ability to bend without breaking. Wood is lightweight, and it can also bend slightly, not as much as steel, but it does have the ability to give a little bit. In contrast, if you're looking at like a concrete block building or a brick building, those are less likely to bend, and they break and they crack and they would crumble. And so stone and concrete are not a great idea. And we're looking into, and when I say we, I mean structural engineers, are always looking into other materials that they can use, man-made metals that are more flexible, or things like bamboo, anything that would help build a structure and make it a little bit more flexible. Okay, so I love this picture, by the way. Take a look at how this crack formed, and just pieces of this earth have just separated and moved. And notice you don't see cars, you see people walking, trying to get out of there because of the damage. Okay, so for our last lesson, I just want you to watch how we design buildings to survive earthquakes. It's a little clip about some of those things I just discussed. And then I want you to complete the exit ticket, lesson 7 exit ticket, which is solely about earthquakes. And there's 10 questions for you. And then that's it. That's the end of our plate tectonics unit. It's crazy. It went fast. If you have any questions at all, please send me a message and I will try and help you as much as possible. Or we can schedule a Google Meet session if you want some live tutoring or if you have some questions. Okay, guys. Thanks for tuning in, and I will hopefully talk to you soon.